everyone. So today we are going to solve 28th August Gigs for Gigs problem, that is minimum cost selection. What we have given is we have given a 2D matrix that can have n row and three columns. Column numbers are the fixed, and where each row represent the cost of three available choices at a shop. So what is the meaning of this? Like we have given, like, consider these three items, three available choices, and this is one choice two, choice three. We can do shopping at a shop, and we have to find the minimum total cost that is required. Okay, so let's take this example and go to whiteboard. What the problem is saying in the detail we can see. So this is the problem statement, and if you see, if we write what it is, like 150, and the third element is also 50, second row is 50, 50, 50, third row is 150 and 50 again. So we have given a condition. Consider, for in each and every row you have to but take particular element, you have to choose particular choice. Consider this is choice 1, choice 2 and choice 3. If you're taking any particular choice, consider you are taking this one, so you cannot take this choice at the adjacent row. Okay, if you are taking this particular choice in this in this row, so you cannot take in the next row this particular choice. So basically in the two adjacent rows, the choice that you have taken, the those should be unequal. Okay, so consider, and I have to find the minimum total. These are the cost that we have given for the three items, and we have to find the minimum total cost that is required. So consider if I'm taking one, okay, let's start. If I'm taking choice zero at the row number zero, okay, row number zero, and I'm taking the choice zero, okay. So this is choice 0, 0, 1, 2, and if I'm taking this one, can I take this one? No, I cannot take this one. Can I take this? Can I take this? Okay, so it means for the row number one, I have two choices. Okay, either I can take this one or either I can take this one. Okay, if I'm taking this one, okay, if I'm taking this one, can I take this one? No, for the third row, I can take this and this. So I have basically these 1 and 50. These I can take. If I'm taking this one, can I take this one? No. So I can take 1 and 50 again. So I can take 1 and 50. If you're summing it up, it will give you 52. It will give you 50, 50, 100 and 1, 101. And it will give you 52, and it will give you 101. So what is the minimum cost? Minimum total cost is 52. So basically, this is the problem statement. So what we have to find out. So our main purpose is, for each and every row, we have to take one element, and we cannot take the again that particular element in the second row. Okay, this is the simplistic problem statement that we can conclude from this. Okay, so let's start this, like how we can think of. Let's start from the basic approach as a beginner level. What I can think of. So in the basic approach, like consider I have some black box function. Okay, I have some black box function. I will pass some input that we required. What we required? Consider I'm at row number one. Okay, starting from row number one. What I required? I required this, first of all, complete matrix that I required. That is must, because we need to calculate the cost. Second thing is, in which row particular I am present. Okay, so I need current row. C row I need, in which particular column that I've taken the in the previous row. Okay, so consider if I am at the row equal to 1, at row equal to 0, what particular column that you have choose. So that I need. So basically, what is the previous column that I've chosen? So these three details I need. If I pass these three details in the black box function will return me minimum cost required from that particular row. Taking consideration of that previous column, you will get the minimum cost. Okay, so consider something, we have the this black box function, it will give us this detail. Okay, so let's see in the detail. Let's erase this and think how we will do this. Okay, so consider this is the minimum cost. This is the black box required. Okay, so consider I have again starting from 0, 1, 2. This is row 0. This is row 1. This is row 2. This is 0, 1, 2 column, 0, 0, 1, 2 column, and this is 0, 1, 2 column numbers. Okay. So let's start with the row number 0. And what I will do is I will take the first element and I will pass the details in the black box function, and I will expect the minimum cost that is required. Okay, so if I'm taking the 0th row 0 value, so what is the cost? That is 1, that will contribute 1. And what is the, like, consider this is our black box function, but what we will pass in this. So we will pass matrix. that is the input matrix, and the row number that we need to calculate. So row number, if I'm taking the zero number row number, so I need to pass the one. So I will pass one. Okay, because from the further row I need the minimum cost. And if I took the zero column, okay, zero column, so I can take one and two columns. Okay, so I am passing the previous column that I have took. So it will give me the minimum cost required from the first row and consideration of the previous column as zero. Okay, consider if I'm taking the this particular, so it will give contribute to 50 plus black box, same matrix. Okay, and second row is one and previous column is one. Okay, and the third one is 50 plus black box and consider matrix. And what is the this is first row, because first row we have to start and I have took the second column. Okay, if we will do minimum of all these three, I will get the answer, I will get the output minimum cost required, because this is contributing one. I am getting the black box function, this is 50, I am getting taking care of the black box function, I am 50, I am the black box function. Okay, so it will going to calculate for each and every combination and it will give us the minimum value. And how this black box function will work, consider this is a black box function, we have starting matrix. Okay, and I'm start going to start from zero and I have not take any column. So consider this is the initial point, so it will starting from here. Okay, so hope you understood what I'm trying to say is how you will first thing you have to understood what is the approach, what is the problem statement is saying. Second thing is how you will start at the beginner level. Don't think directly from the like optimized level. Okay, if you are a beginner level or if you are a mid level, I would suggest to try to think what you can what you are interpreting from this. Okay, try to write the statements. If you write these statements, you will understood what is this problem is saying. It is repeated manner. Okay, it is a repeated manner we are going to say. Okay, so consider this index. What is the final condition? Like it will call black box of mat 10, then it will call black box of mat 20, consider black box of mat 30. But where it will going to be stopped? So we will going to be stopped when our index out of the bound. Okay, when my index is mat dot length, I will stop because there is no requirement to going further. Okay, so this will be the base case condition, upper bound condition that we will stop. Okay, so hope you understood this. We will write quickly code for this, and let's see. I'm going to write the code in Java. If you are comfortable, you can refer this. Otherwise, you can take a reference from here. Okay. So I'm just taking variable as n, and consider I have some min cost value, min cost r, and I'm initializing with some maximum value, infinity value. Okay. Positive infinity value. And what I'm going to do is for int column equals to 0 to column. We have fixed three values. Okay, column 3. And what it will contribute minimum cost r, that will be math dot min cost r it will contribute, and minimum cost r we need. And what will be the black box function? Consider this is the black box function. We will pass matrix, and this is row 0. We are going to start from the row 0. You can start from the -1 also that I've explained here. And you can take the row 0 as the initialization point, and row 1 you can start from the further. Okay. So for easiness, I'm starting from the row 0. So the next row will be 1. And the previous column I have taken as a column. Okay. And this will give us the minimum cost R. Okay. And we forgot one thing, what it will contribute. So it will contribute mat of current row is 0 and column is this one. Okay. So this what it is saying is you are contributing mat of current row, that is 0, current column that you are contributing, and you are going to take the minimum cost from the further rows. Okay. This is row 1 and you have taken the previous column as the call value. Okay. So this will give you, so light the black box function, private int black box function. This will be int mat, and this will give consider current row and previous column that we have to. Okay. So if my case, first write the base case. If my current row, if I'm over out of the bound of the current matrix length. Okay. So I'm just simply return 0 because I don't need to do anything and it will not going to contribute anything. So I will return 0. Okay. This is the base case. Now the other case is, so I will iterate over for this particular current row for consider column equals to 0 to 3 and column plus plus. I will check if my current column should not be equal to previous column, because two adjacent same value we cannot take. Okay. If it is not, and consider I have a variable that is min cost r, that will take care of, and I'm initializing it with maximum value. Okay, so this will be, and same manner, min cost r will be math dot min cost r. Okay, and what I will take is I will take the black box function of matrix current row plus one, because next row I need to go, and I'm taking the column as the like as the value, so it will pass as the previous column that will be going to contribute, and plus, and particular current row, this will be value that we are going to take from the current value. Okay, current row, and our column is the this one. Okay, and finally we will return the minimum cost r that we got. Okay, so let's see int n. Okay, you are initializing the maximum value and you are going to iterate over the each and column. So this is the for the first initializing point. Okay, so I'm starting at the row 0 and I'm passing the row number 1 and the previous column that I have taken. And here I'm taking, like, if the column equal to 0, so 0 to 3, and if column is not equal to previous column, it means I'm checking like this should not be equal to, because in two adjacent rows we cannot take the same column number. Then I'm calculating the cost for the black box function current row plus one, and I'm passed the current column that I have took, and this is the contribution that current column will give us. Okay, so let's try run this. Okay, for okay, where it is spelling mat dot minimum plus minimum cost star, that is integer. Okay, let's do this integer dot maximum column mat of current row, that is 0, and column you are passing mat dot minimum cost star, and mat one column. Okay, return the minimum cost star. Okay, and mat current row and previous column. Current row is the mat dot length, then I am passing the return 0, and integer dot max column. I'm okay. If column is not equal to previous column, then I'm passing that as the black box current row plus one. Okay, and I am passing the column number. That will be okay. Sorry. So this will be how it will contribute is minimum cost star. So math dot minimum of minimum cost star whatever I have, and it will contribute this thing. Yeah. So let me write like this. Okay, minimum cost star, because current cost we have, and it will contribute mat of current row column and black box of this one. So whatever value we are going to get will return the minimum cost star, and similarly here we have done minimum cost, so it will contribute like this. Okay, so okay, minimum cost star and black box of this one. Okay, yeah, so it is working fine. Let's try to submit it. Yeah, so here you can see we are able to pass like 10 test cases. Why it is TLE is given? Because for every row we are going to checking for the each and every row in the detail. There are overlapping problems in this. Okay, let's see how it is. So in this example, black box of mat 10 we are calculating. Then what it will call? It will call black box of mat. Okay, consider mat, and the second row column 1 it will call black box of mat row number 2 column 2 it will call. What it will call? It will call mat. Okay, row number 2 column 0 it will call, and it will call mat of 2 2. Okay, so you can see this one and this one, these are overlapping problems, right? In this current example we are calculating for this one also and this one again and again. Can't we do like store this value so that we can use it further if it is required? Okay, so we can use the dynamic programming here. It is nothing but if you don't know dynamic programming or nothing about it, it will be just simple 2D array that you are going to store the values and you are going to access them whenever you are required. Okay, so I'm creating 2D DP. Why? Because we have two variables that are changing in our code. Okay, current row and previous column. Okay, so I'm creating this 2D DP to store these values. And what is the current row range? Okay, think about this. What value can minimum current row can take and maximum? Current row can start from 0 and current row can go to the n. Okay, mat dot length. So it will this one and previous column. So previous column what is the range of previous column? Previous column can be start from 0 and can go to up to the 3. So 3. Okay, like this only. And I am initializing the DP array with -1 so that we will check like where if if I'm initializing it by -1 and I will check in the our function if that value is not equal to -1, it means like that value for that particular DP, that particular combination we have already calculated and we will use that. Okay. So arrays dot fill. This is just a Java notation. If you are DP of I -1, why I'm initializing with -1, not with 0 or something, because -1 cannot be possible in this combination. Okay. So that's why I'm using the -1, because you can see every number is positive integer. So -1 cannot be possible. Okay. And I'm going to pass just in DP array in our black box function. And I'm going to use this DP function directly here. And I will just add a condition if my DP of current row that I'm going to evaluate and my previous column is not equal to -1, it means I have already calculated the value of this. So I will just return current row and previous column. Okay. And if I have not calculated the value yet, it is just -1. So I'm going to calculate the value and I'm going to store that value for the further iteration. Okay. And I'm going to pass the TPA. Okay. Nothing but just that's it. Yeah. Try to submit it. It will work. Okay. So yeah, it is working. So now you can see like how easily we can solve this problem. Now the third optimization. Okay. So now what is happening is what we are doing is we are storing these values. We are going to use those values. Okay. Now it's like solve the problem. But what if do we require this everything? Do we require like to go over the black box function and to checking? Let's see the example once more time. Okay. What it is saying is consider 150. This is not a time and space optimization. This is just a like you can say a code optimization for better code readability. Okay. So 150 we have given and this is 50 50 we have given and consider third is 150 and 50. Okay. So consider I am at the row number 1. What I need, if I'm starting at row number 0, I need the minimum values that I've till now that I've got from these two indexes. Okay. If I got somehow the minimum value from this particular and this particular thing, I can add this contribution that exactly I'm doing in this recursion also. But in the simplistic manner, if I'm telling like if I'm adding this value to this contribution, I will get the minimum value for this one. Same for exactly this one. This one it will contribute 0 and 2, and for third one 0 and 1. Okay. And for the second row again, now I have the minimum value still here, and I'm going to use those values to find out this one. This algorithm will work if we have the fixed number of columns. Like in this case, we have a fixed number of columns, 3 columns. Okay. If we have considered in the this problem is expanded to n rows and m columns. Okay. Then this problem can be very this algorithm will not work because you have a m number can be vary. Okay. So you have to define the fixed number of the values. Okay. So what I'm trying to say here is if I'm to start from the row number 0, okay, I'm taking the this value as a previous 0. Okay. This is previous 0. This is previous 1. This is previous 2. I'm going to start at the row number 1. Okay. But this value is contributing. This will contribute 50 plus minimum of previous 1 and previous 2 because I cannot take previous 0. Okay, I cannot take previous 0. So it means I can take previous 1 and previous 2. So minimum of 50 comma 50, that is 50. Okay, so this will it will contribute for second one 50 plus minimum of it will contribute. This is first index, so it will get the value from 0 and 2 because this we cannot take. So it will be 1 comma 50. Similarly, third one 50 plus minimum of 1 comma 50, and these values will be going to be contribute to the then second row. Okay. Similarly, we can find out the then further details. So this problem is nothing but it is very simplistic algorithm like what we are going to do in 10 and consider I have defined some initially value that is previous one and my starting with the first row that is row number 0 and row 0 int previous one that is mat of row 0 and value 1 in previous 2 that is row 0 and value 2. If I'm going to start from the further point for int I equals to n, similarly in the recursion we are doing initializing for the 0th row and starting from the first row. Okay, that I'm doing here. So I am finding, let's suppose what is the current row. So if I'm taking the previous 0 value, okay, If I'm taking the current row, consider the more for better readability. I am defining this as row 1, row n, and row plus plus. Okay. So if I'm taking this current row and value as the current column, so what I will take as the minimum value? I will take previous one and previous two, right? I can take this one. If I'm starting from the current row 1, okay, this is current row and I'm taking this one. So mat dot minimum, I will take the previous 0 and previous 2. Similarly for current 2, I will take mat of row of 2 plus mat dot minimum of previous 0 and previous 1, because we cannot take the same columns. And similarly, I can define the now my previous 0 will become current 0, because for this from this row, now my values are this one. Okay, for the further rows, current 1 and previous 2 will be current 2. And finally, when I'm out of the boundation, then I will just return the minimum of whatever the value I can till now concluded, that is previous minimum of all of those three, previous 1 and previous 2. Okay, so let's try to submit this. And if I'm submitting this problem, yeah, it is working fine. This is just a big of n approach. We are not using any extra space. So big of n, time complexity and space complexity is big of 1. Okay, so there are total 3 approaches. You can start from, I would highly recommend you start from the brute force approach. Think about this, see where it is lacking, then go for optimization and then go for the final optimization. Okay. So hope you understood the problem. If you got learn something new, please like and subscribe my channel. And I'm trying to upload the videos for the daily problem of the day. And I'm also working on the tree playlist. So if you have not watched yet, please watch it. So thank you, everyone.